Welcome to the Cabinet of Science and Fiction. Today we're diving deep into a concept that, well, it's captivated thinkers for literally millennia, and it's seeing something of a modern comeback. The ether.
Absolutely. For centuries, this idea of a, subtle, all-pervading something filling space was really a cornerstone of scientific thinking. We're going to explore its roots, way back in ancient ideas, right up to its big role in 19th century physics.
Where it was seen as the medium for light, for electromagnetic waves, that kind of thing.
Exactly.
And we'll definitely unpack why it seemed to fall apart after the Michelson-Morley experiment and, of course, Einstein's special relativity. But maybe more importantly, we'll look at how Einstein himself actually came back around to a revised idea of the ether with general relativity.
Right. Our mission today is really to trace that whole fascinating journey and explore this modern idea, the neo-aether, how current physics, quantum mechanics, cosmology, suggests space is anything but empty. It seems to have real, measurable physical properties.
So get ready for some surprising connections, maybe a few aha moments along the way.
Hopefully.
Okay, so this idea that space isn't just emptiness, that it's something fundamental. It's been around a very long time, hasn't it?
Oh, absolutely. Millennia.
Yeah.
If you go back to the Vedic scriptures, you find this concept of prakriti, basically the universe, space itself arising from a fundamental vibration and a life force.
The vibration.
Yeah, and this vibration supposedly gives rise to 5 subtle elements. The very first one, akasha, which is pretty much what we call the ether.
Okay.
And this akasha is then acted upon by prana, the sort of creative energy that makes everything happen. So yeah, the core idea of an active fundamental space is ancient.
That sounds remarkably like the ancient Greek idea of quintessence, the fifth element beyond earth, water, air, and fire.
It really does. Philosophers like Aristotle, they saw quintessence as this primordial, indestructible substance, the foundation for the other 4 elements.
So not just passive stuff.
No, not at all. It was often tied to, divine thought, the power of creation itself. I mean, the Greeks and Romans even worshipped pater, omnipotence aether, the all-powerful ether. So this idea, it just keeps popping up in human thought.
And this philosophical idea, it eventually made the leap to science, right? It wasn't just abstract thinking anymore.
Exactly. Fast forward to the 17th century, and you've got Descartes bringing the ether firmly into scientific discussion. He argued against empty space, said interplanetary space was a plenum, completely filled.
A plenum.
Yeah, filled with this subtle substance. He saw this ether as the carrier for both force and light, a sort of boundless, infinitely divisible stuff filling everything. That was a big shift, moving towards a more mechanistic view of the cosmos.
And then as we started figuring out, light behaves like a wave. Well, waves need something to travel through, don't they? If space was empty, what was waving?
Precisely the question. Huygens was the first to really formalize this with the idea of a luminiferous ether, a light-bearing ether, the medium for light waves where there's no ordinary matter.
How did he picture it?
He thought of light as longitudinal waves, kind of like sound, moving through a stationary ether made of tiny particles. And interestingly, even Newton, who initially pushed for a particle theory of light.
Right, corpuscles.
Yeah. Even he later talked about an ether that varied in density, maybe as a way to explain gravity. So you see, even the giants of early physics felt the need for some kind of underlying medium.
So by the 19th century, the ether was pretty much standard scientific thinking, like part of the toolkit.
Oh, absolutely standard. In astronomy, it was mostly seen as this incredibly thin fluid that planets could just glide through without resistance. It even formed the basis for some early fluid dynamic theories of gravity.
And in physics?
In physics, it kind of had 2 jobs. First, the obvious one, the medium for light waves, for electromagnetism. But second, to explain things like dispersion, how light splits into colors, and polarization, how it vibrates in specific directions.
Right, like with polarizing sunglasses?
Exactly.
Yeah.
To explain that, scientists figured the ether couldn't just be a simple fluid. It'd have some kind of almost atomic-like semi-solid structure, something with incredible elasticity to support those transverse waves like ripples.
So it evolved from just a smooth substance to something more complex.
Yeah, definitely. From this continuous, uniform idea to something with a more, granular or structured nature. It was quite an evolution in thinking.
Now, Faraday, he seems to have had a really unique take on the ether. It wasn't just a passive backdrop for him, was it?
No, not at all. Faraday's view was quite revolutionary, actually. He thought, well, if the ether exists, it can't just be passively transmitting stuff.
Okay.
Influenced by some earlier ideas, he suggested that lines of force, like the patterns iron filings make around a magnet, weren't just mathematical tools. They were real physical disturbances in the ether, propagating across space. He even pictured atoms not as tiny billiard balls, but as centers of force that literally extended throughout all of space. The forces carried by the ether were maybe even more fundamental than the matter itself.
And he had that model with the rotating tube.
The vortices. Yeah, his model of force lines as these rotating, fluid-filled tubes, these forces, it was incredibly forward-thinking for its time. He saw the ether as an active participant.
Which then leads directly into Maxwell's work on electromagnetism, right? He really built on Faraday's foundation, using this ether idea.
Precisely. Maxwell took Faraday's insights and developed this incredibly detailed mechanical model of the electromagnetic field. He imagined space filled with these microscopic whirlpools, the vortices in the ether fluid.
Okay.
And these vortices were separated by tiny idler particles, like little ball bearings, that could mesh with the vortices without friction. He equated the flow of these idler particles with electric current.
Right.
And changes in how the vortices rotated. That was the induced electromotive force, the thing that drives currents.
And this model actually worked.
It works spectacularly well. Using this mechanical analogy, Maxwell managed to calculate the speed of light with amazing accuracy. He realized light was an electromagnetic wave moving through this ether.
That's incredible.
And then in his 1865 paper, he went further, deriving a whole fluid dynamic theory 20 equations, describing electromagnetism, all based on this idea of an ether-filled space.
And the whole vortex idea didn't stop there. Thomson, Lord Kelvin, he picked it up too.
That's right. Thomson, or Lord Kelvin as he's often known, tried to use vortices to explain atoms themselves. He was trying to bridge the gap between this continuous ether and the growing evidence for discrete atoms.
How did that work?
He modeled atoms as stable, swirling vortex rings within a perfect fluid ether, incompressible. No viscosity based on some mathematical theorems about fluid motion from Helmholtz.
So atoms were like little smoke rings in the ether.
Kind of. In theory, these vortex atoms could interact, bump into each other, but they couldn't be created or destroyed. Maxwell actually incorporated these ideas into his big work, the Treatise on Electricity and Magnetism. It was all part of developing this picture of the electromagnetic field.
So the ether seemed rock solid, a foundation for physics, until the Michelson-Morley experiment. That's usually painted as the nail in the coffin, isn't it?
That's the popular story, yeah. But like a lot of science history, it's a bit more nuanced. Michelson and Morley set up their famous experiment specifically to detect the ether wind.
The drag from Earth moving through the stationary ether.
Exactly, like feeling the wind in an open car. They used an interferometer, a very precise instrument, to measure the speed of light traveling in different directions relative to Earth's motion. They expected to see a difference about 30 kilometers per second, based on Earth's orbit.
But they didn't find it.
Well, they didn't find the expected 30 kilometers per second, that's true. But their results weren't actually zero. They measured a much smaller effect, maybe 8 or 9 kilometers per second.
Huh. So not quite null.
Not quite. But the scientific community at the time largely interpreted it as a null result, as evidence against the stationary ether. Michelson and Morley themselves were actually more cautious.
And it wasn't like everyone just stopped looking after that one experiment, was it?
No, definitely not. In the 1920s, a physicist named Miller performed even more precise versions of the experiment over many years at altitude. And he consistently measured a small positive effect, an ether wind of around 10 kilometers per second. Consistent results.
So why isn't that talked about more?
It's complex. There were debates about experimental errors, interpretations. And interestingly, some modern analyses, like Cahill's, suggest the type of interferometer matters. He argues that vacuum-based interferometers might inherently mask the effect due to refractive index issues, while gas-mode ones consistently show the small, non-zero 8-10 kilometer sec effect.
So the experimental story is actually messy.
It's definitely messier than the simple null result kill the ether narrative.
But regardless, Einstein's special relativity arrived in 1905, and it kind of swept the field, didn't it? And it famously didn't include the ether.
That's the key point. Einstein's theory was revolutionary precisely because it was built on just two simple postulates. One, the laws of physics are the same for everyone moving at a constant speed. Two, the speed of light in a vacuum is constant for everyone, no matter how the source is moving.
And that just worked without needing an ether.
It worked beautifully. It explained relativistic effects without needing a medium for light. In fact, the whole idea of a stationary ether implied a sort of absolute rest frame in the universe, a preferred reference point.
Which violates the first postulate.
Exactly. It contradicts that principle of relativity, or Lorentz invariance, the idea that physics looks the same for all inertial observers. Special relativity just elegantly sidestepped the whole messy ether debate by simply not needing it.
But here's the twist, right? Einstein himself, he didn't completely abandon the idea forever.
That's the really fascinating part. Later on, with his 1915 general theory of relativity, where gravity isn't a force but the curvature of spacetime.
Right, space itself bending.
Yeah. Einstein realized he needed something like a medium to explain inertia, how gravitational effects propagate. Things related to Mach's principle, sometimes called Mach's ether.
So he brought it back.
He did. By 1920, he gave a famous lecture where he said, and I'm paraphrasing slightly, according to the general theory of relativity, space without ether is unthinkable.
Wow.
But, and this is crucial, his new relativistic ether was not the old 19th century rigid absolute thing. It was dynamic. It was basically space-time itself, endowed with physical qualities, influenced by gravity, by matter and energy. Very different.
So the old ether died, but a new kind of concept, this neo-aether, started to emerge from 20th century physics.
You could put it that way. As physics developed, especially with quantum electrodynamics QED, the theory of light and matter interaction and our understanding of gravity deepened. The focus shifted to the vacuum itself.
What we used to think of as empty space.
Exactly. And we discovered it's not empty at all. The physical vacuum has real measurable properties. Things like elasticity, permeability, impedance, ways it responds to fields and forces.
So it's like a substance.
It led to this concept of the quantum plenum, or quantum vacuum, a dynamic, substantive medium, seething with virtual particles popping in and out of existence, full of energy fluctuations.
Neo-aether.
Right. And this neo-ether idea suggests maybe matter itself isn't fundamental, but just a dynamic state, like a whirlpool, in this deeper background. And it might help explain really weird stuff like quantum non-locality or just how light manages to travel through empty space.
And there are specific discoveries or theories that seem to point towards this kind of active vacuum, aren't there?
Yes, several key things bolster this view. You've got the Sagnac effect from 1913. Using a rotating interferometer, it shows a sensitivity to absolute rotation against an inertial frame. Some see that as direct evidence for a background medium. Then there's the zero-point energy of the vacuum. This came out of Planck's work, quantum mechanics. Basically, even at absolute zero temperature, space isn't quiet. It's filled with these irreducible energy fluctuations.
0-point energy.
Right. The physicist John Wheeler was a big proponent of this, suggesting this quantum plenum, with its truly immense energy density, might be more fundamental than particles. These ZP fluctuations are seen as the source of quantum noise, and they seem to be self-regenerating.
And what about the Hardon of Bohm effect? That's the one where particles feel something even when there's no force field, right?
Exactly that. It shows that charged particles, like electrons, can be influenced by electromagnetic potentials, even in regions where the actual electric and magnetic fields are zero.
How does that relate?
It suggests these potentials, which we often thought of as just mathematical tools, might have a real physical significance. It hints at some deeper structure or energy reservoir in the vacuum that classical physics missed.
And didn't Dirac, one of the fathers of quantum mechanics, also revisit the ether idea?
He did, yes. In 1951, Dirac proposed a quantum mechanical version of the ether. He applied Heisenberg's uncertainty principle to the ether's local velocity, basically saying you couldn't know its exact speed at every point.
How did that help?
It helped reconcile the idea of an underlying medium with the principles of relativity, which seemed to forbid a fixed frame. His work ties into QED, where the vacuum is this sea of virtual particle-antiparticle pairs constantly popping into existence and annihilating.
And this framework explains actual observed phenomena.
Oh, yes. Things like the Lamb shift, a tiny energy difference in hydrogen atoms, the electron's slightly off magnetic moment, why atoms spontaneously emit light, the Casimir effect, vacuum polarization, even the Unruh effect, where an accelerating observer perceives heat in a vacuum, all tied to this active quantum vacuum.
Let's talk about the Casimir effect. That's the two plates in a vacuum getting pushed together.
That's the one. Predicted by Hendrik Casimir, later measured experimentally. If you place two uncharged metal plates very, very close together in a vacuum, they attract each other. The explanation involves those zero-point energy fluctuations. Basically, only virtual particles with wavelengths that fit into the tiny gap between the plates can exist there. Outside the plates, all wavelengths are allowed. This creates an imbalance, lower energy density inside, higher outside, resulting in a net inward pressure pushing the plates together.
And the closer the plates, the stronger the force.
Exactly. It depends strongly on the distance. It's seen as direct experimental evidence for the reality of these vacuum fluctuations.
What about David Bohm's interpretation of quantum mechanics, the quantum potential idea? Does that link to a neo-aether?
It's definitely related in spirit. Bohm's interpretation, building on de Broglie's earlier pilot wave concept, offers a different picture of quantum reality. He proposed this quantum potential, a kind of information field guiding particles.
Guiding them how?
It represents what Bohm called the unbroken wholeness of the entire universe. It's like an underlying reality that influences particle behavior. Basil Hiley, who worked with Bohm, even suggested particles are just excited states of this deeper field, and the quantum potential is part of that field structure.
Does that require some non-standard assumptions?
It often does involve looking beyond purely physical explanations, potentially touching on metaphysical ideas about interconnectedness and the nature of reality itself.
And turning to the universe at large, cosmology seems to have stumbled upon its own version of a space-filling something with dark energy, hasn't it?
Absolutely. The discovery in 1998 that the expansion of the universe is actually accelerating was a huge shock. The explanation, dark energy, some mysterious energy that seems to permeate all of space and pushes everything apart.
And most of the universe.
According to the Standard Model, yeah. About 68% of the universe's total energy density is thought to be dark energy. And some researchers, like L. Nasky, have explicitly suggested that maybe the ether is the thing that stores or manifests this dark energy.
Then there are even more unconventional ideas, like Laviolette's subquantum kinetics.
Right. Laviolette proposes a unified field theory based on what he calls a transmuting ether. This isn't just a passive medium. It's a highly active, energetic subquantum reality from which matter and energy emerge.
Transmuting.
Yeah, constantly changing and evolving. He models it as an open system, meaning it can exchange energy with its surroundings and even exhibit negentropic processes, creating order out of chaos, which is unusual in physics. And he argues this framework can actually accommodate relativistic effects too.
It's really striking how this idea of an ether or something like it just keeps resurfacing in different scientific contexts.
Yeah.
It makes you wonder about the deeper, maybe even metaphysical layer beneath it all.
It really does. You know, historically, many core scientific concepts, atoms, forces, the ether itself, had deep roots in or connections to metaphysical thinking. And let's be honest, even today, science hits limits. We still grapple with fundamental questions. What is space? What is matter at its most basic level?
And metaphysics often tackles those questions differently.
Often, yes. Some metaphysical views might see forces not just as interactions between matter, but as primary aspects of reality itself. Or consider concepts like the Vedic Akasha, this omnipresent source or essence of all energy. In these frameworks, the forces we observe might be effects bubbling up from a deeper reality, not the ultimate cause.
It's also interesting how some thinkers, even centuries ago, seem to anticipate modern ideas from a more, well, metaphysical perspective.
Definitely. Someone like Blavatsky, writing back in the late 1800s, talked about the universe emerging from a seeming void that was also a divine plenum, which sounds oddly like our modern energetic vacuum, doesn't it?
It really does.
And she, along with many traditions, emphasized this idea of an interconnected cosmic intelligence. Metaphysics also often talks about different planes of reality, suggesting our physical world might be influenced by, or even be a projection of, higher or subtler realms.
There's definitely been a historical split, though, between mainstream science and these more spiritual or metaphysical ways of understanding things.
Oh, absolutely. Science, especially after the Enlightenment, tended to focus on the measurable, the material, the quantifiable. Consciousness, purpose, deeper meaning again, those were often left to philosophy or religion.
But maybe that's changing, or could change.
Some people think so. The psychologist Charles Cart had this interesting idea of state-specific sciences. He suggested that different states of consciousness, meditation, dreaming, etc., might actually give us access to different kinds of knowledge, reveal aspects of reality hidden from our normal waking state.
So science itself might evolve as we evolve.
Perhaps. Maybe as our understanding of consciousness deepens, that old rift between science and spirit could start to heal, leading to a more whole picture. The idea that the invisible, the metaphysical, might actually govern the visible, the physical. It's a profound thought. A closer relationship could be very fruitful.
Okay, so if we run with this idea of a dynamic neo-ether, this energetic quantum plenum,
Right.
what are the potential implications? Where could this lead?
Well, the implications could be absolutely massive. On the practical side, think about energy. If the vacuum really holds this enormous zero-point energy,
Can we tap it?
that's the billion-dollar question, isn't it? Tesla certainly believed we could get free energy from the environment, inspired partly by those Vedic ideas of Akasha. His work was controversial and ultimately thwarted, but the idea persists.
Are people still working on it?
Yes, there are theoretical proposals, like Robert Forward's idea of extracting energy using the Casimir effect. And there are ongoing claims, often debated, of over-unity devices that supposedly tap into this vacuum energy. It's theoretically possible in open systems, but proving it is hard.
What about things like anti-gravity?
That's another potential long shot. If gravity itself is somehow related to these vacuum energy fluctuations, as some theories propose, then maybe manipulating the neo-ether locally could counteract gravity. Highly speculative, of course, but theoretically conceivable within some frameworks.
And the connection to consciousness. That seems just as mind-bending. Could this neo-ether actually be conscious in some way?
That's where things get really profound. Some theories don't just see the vacuum as energetic, but potentially possessing some form of primordial sentience, a fundamental unity of consciousness and matter right at the ground state of reality.
So consciousness isn't just in our heads?
Maybe not exclusively. Perhaps consciousness is a fundamental property of the cosmos, and our brains act more like receivers or filters, allowing us to experience a localized stream of it.
And could our thoughts affect this field?
That's another fascinating speculation. If focused intention can somehow interact with or influence the quantum plenum, maybe that's a physical basis for phenomena like psychokinesis, mind over matter, or intentional healing, or even action at a distance that defies classical explanation.
What about things like breatharians, people who claim to live on energy, not food? Is there any potential link there?
It's an intriguing thought. The phenomenon breatharianism, or Big U, in ancient China, where people claim to subsist purely on cosmic energy or quad. Well, if there's this ambient energy field, perhaps they've found a way to tap into it directly for biological needs.
Like transducing zero-point energy.
Possibly. It connects to ancient ideas about a universal life force and the interaction between organisms and their energetic environment. And while controversial, there have been some controlled studies suggesting, for instance, that external kaya projected by Kagong masters can have measurable positive effects on cell cultures. It hints at some kind of fundamental bioenergetic interaction.
Okay, one last area. The Akashic records. This idea of a universal library holding all information. How might that fit into an etheric view?
The Akashic records are usually described in metaphysical terms as this vast repository of every thought, event, emotion, intention, encoded onto a subtle etheric plane.
No scientific proof for.
No direct scientific proof, mostly anecdotal accounts and spiritual traditions. But conceptually, if you think of the neo-ether as a fundamental information-rich field permeating everything, well, the idea of a universal memory bank doesn't seem quite so outlandish.
Should things like telepathy tap into that?
Some speculate that yes. Perhaps intuitive insights or telepathic connections involve accessing information stored non-locally within this field. There's even a really wild idea that as our solar system moves through the galaxy, Earth imprints a record of its state onto the neo-ether it passes through,
Leaving a trail.
like a vibrational trail, and maybe traversing different regions of space with different etheric vibrations could subtly influence us. It echoes ancient beliefs about cosmic energies influencing world events and consciousness. Highly speculative, but thought-provoking.
Wow. This whole journey of the ether, from these ancient philosophical ideas right through to modern quantum physics, it really shows how persistent we are in trying to grasp the fundamental nature of reality, doesn't it?
It really does. The concept keeps evolving, changing its form, but it consistently offers these intriguing possibilities for unifying how we see the cosmos, linking energy, matter, maybe even consciousness itself.
The idea that space isn't empty, but this dynamic, energetic medium, it really challenges our basic assumptions. And it opens up so many exciting avenues for exploration, scientifically and philosophically.
Absolutely. It forces us to rethink emptiness itself.
So we really encourage you, listening, to think about these implications. What could a neo-ether, this energetic quantum plenum, mean for your understanding of the universe and your place in it? What puzzles might it solve? What new questions does it raise?
It certainly gives you a lot to ponder.
Until next episode.